So our next topic is going to be where functions meet. So what we have to do is find out at what points functions are going to meet. Now functions don't have to be linear. They could be quadratic. They could be all kinds of different things. We got to be able to figure out different scenarios. Now if we consider a quadratic and a linear function, and they're drawn on the same set of axes, there are a couple possible situations. Well, the line could cut through the quadratic and you will have 2 points where they intersect. You could have where it touches the vertice, and in that case there's only 1 point of intersection. And finally you get the other case where the line just completely misses the quadratic. If these lines meet, the coordinates of the points of intersection can be found by solving two equations simultaneously. Oh no, here we go. So how are we going to do that? Well, we'll take this particular example. We want to figure out the coordinates of the points of intersection of the graphs with the equations. So when does this meet this? The one thing that we can say is, I'm going to write it this way. Y equals. I'm going to pause for a second because y is equal to x squared minus x plus 3. But y is also equal to 2x plus 7. That only happens when the functions intersect. But one thing we know, y is equal to this, and y is equal to x squared minus x plus 3, and y is equal to 2x plus 7. So what we're going to do is move this. We'll just get rid of it. And we'll make the two equations equal to each other. Now what we have to do is figure out a way to solve for x. Well, if we know there's a quadratic, the one thing that we normally would do is make one side equal to 0 and bring everything over to the other side. So what we're going to do now is I'm going to subtract 2x and subtract 7, which means I have to subtract 2x and subtract 7. When I do that, I'm left with x squared minus 3x minus 4 equals 0. So we can move on to the next little bit. And now we know we have a quadratic, so we get a factor. What times what equals -4. When I add them together, I get -3. Well, -4 times +1 is -4, and -4 plus 1 is -3. So I have x minus 4 times x plus 1 will equal 0. Two possible x solutions, x equals 4 or x equals -1. Great. Now what? Now we have to take our original equations and sub in for x to solve for y. I'm going to take the easy one, the 2x plus 7. So if y equals 2x plus 7, then y equals 2 times 4 plus 7, which equals 15, which gives me a coordinate point. Coordinate point or ordered pair is always written x, y, so we're going to have 4, 15. And then we also have y equal to 2 times -1 plus 7 equals 5. So we have another point at -1, +5. Quick sketch, just to give you an idea, what's going to happen is we have a quadratic, -1 and 5, -1, 5, somewhere around there. 4 and 15 is somewhere around there. Quadratics can do something like that. I don't know if crosses, and then we have our linear equation, something like that. I'm pretty sure that's not very good. And we should be able to do this for pretty much the same idea would happen if we had two linear equations that were intersecting. We'd make them equal to each other and solve. And we'll do some practice and hopefully it goes well.